let's see how to create a time series chart in JMP. Now here, let's say we have data on CO2 emissions by a country, and we have yearly data. So here there is a logical hierarchy in terms of the years, year 1, year 2, all the way to year 7, and then 7 happens after 6. So in these cases, we can represent the data using a time series chart. Now to draw charts in JMP is also very straightforward. We go to this graph platform, click on Graph Builder, and then it asks us to drag our X and Y. So it's pretty much drag and drop in terms of the charts. We can make our year on the Y-axis, and I'll make my CO2 emissions on the X-axis. And here the default is like a smooth curve which tries to fit in a curve to this, but we just want a straight line. I'm going to choose this option, and I don't want any error bars. So this, now when I clicked on this, this was fitting a linear line to this. We don't want that. We just want to join the dots in a line. So this just gives us the emission trends that we saw, that the trends emissions were increasing, then there was a dip, then it started going back up again, but then over time they have been very sharply decreasing. So when we have a time series data, a line chart helps us see the underlying trend or pattern in the data. And here we see that there's a pretty sharp dip in the data. Now here we have one series observed over time, but we may also have data like this. Here we have 4 different manufacturers and their production over time. So now we can do a time series chart, but notice there's one problem with the data. This data is not on what we call tidy format. Ideally, if you want to have data in a clean way to do analysis, each column should represent one variable and each row should represent one observation. So here our variable of measure is really auto production, but we have it spread over 5 columns, and then we have 4 different rows. So we need to clean this up so that we have auto production in one column, and then we can have manufacturers in the other. We can also then have year 1, year 2, year 3 as dates. So in JMP, we will first kind of do some pre-processing or tidying up of this data. So there are several steps that we will undertake here. First, we want to stack these columns. So if I click on table, we could also select these. Doesn't really matter, but it'll just be one step easier. I click on tables. Now, again, the table platform in JMP has a lot of very useful options, which will help us do random samples, split, sort, subset. But what we are looking for is stack. We click on stack. And then because we selected those, these 5 columns already selected, we can say stack columns and click OK. So now we have this nicely stacked data set. This is kind of tidy data where we have one column for manufacturer, one column for a year label, one column for our data. Now year 1, year 2, year 3 is still like a categorical, like a text variable. I want to convert that into 1, 2, 3 as if they were continuous variables. Again, the utilities that we had looked at for column, there's one of the options that will be useful here. I click on column, click on utilities, and then I click on text to column. It asks us what our delimiter is. Delimiter is how we want to split the text to column. Is it a tab, new line? In our case, it's a space. I'm going to hit on the space bar and click OK. So now we get these columns split. I don't need this. I can delete this column. I don't need label 1 also. We can delete this column. For label 2, we'll call this time, or we can call this year. We click OK. And then JMP says it is what kind of data it is. We can leave it as continuous or categorical. Let's just choose to continuous. This is our year 1, year 2, year 3. And now we are ready to plot this. So we go to the graph platform, click on Graph Builder. I'm going to drag my year to my x-axis. we'll drag our data, which is really our auto production, to our y-axis. Now we get this like weird thing, but these are all different points for each of the manufacturers. We want a line chart, but now this is all combined. We don't want that. We want to split this by manufacturer. And in JMP, that option is called overlay. So I'll click on the manufacturer column, and then I'll drag it to overlay. And this now creates for us 4 different line charts, one for each manufacturer. GM, Hyundai, Toyota, Volkswagen. And again, the ordering is alphabetical, but now we have hierarchy. So we see that Hyundai has been seeing a steady increase in its cars manufactured. The leading manufacturer, though, is Toyota, which is the top. There was a time when GM was up, but then Toyota overtook GM, and then GM was on a decline. So again, a time series chart really tells us very nice visually how our series, which is over time, has been behaving, the time trends. And again, the data set that we started with was a little messy, but JMP has really cool utilities which help us pre-process and clean the data to get into the form that we can now start doing analysis like that. We did an overlay plot. Had we not done an overlay plot, JMP would have just aggregated the total cars manufactured by each of these 4 manufacturers for each year and then given us just a cumulative or combined line chart. So far, we have dealt with only a series including just one variable. But quite often, we may have more than one variable, 2 or more variables specifically, that may be available to us. And let's see how we can summarize these kind of data. We'll work with cross tabulations, which are kind of like pivot tables in Excel, but we'll do this in our software. And then we'll also create bar charts. And we'll look at 2 different kind of bar charts. We'll look at clustered, which are side by side, and stacked bar charts. Here we have data on 300 restaurants based on their quality rating, as well as the meal price and wait time. So here we see that good, very good, excellent. These are hierarchical ratings. And then we again have 2 quantitative variables, meal and price. So we can start kind of trying to slice and dice this data. We will use the tabulate function in JMP. Let's go to tabulate under the analyze platform. And here I can very quickly kind of see how my average, now sum of prices doesn't make any sense. So we can see average price and average wait time for quality rating. So I can move my quality rating to my rows. We get our count. We have 84 restaurants in the good category, 150 in the very good, and 66 in the excellent category. And we can now move the meal price next to our column N. It lets me, again, I'll just drop it in here. We get our meal price, but it has done the sum. We don't want the sum, so now here we have all the statistics that we can use. We want the mean. I can click on this column, and then instead of sum, right click and then choose statistics. We can choose mean. So we get the mean of our restaurants. And then we can also do the same with wait time. I can drag the wait time, move it next to my meal price. And again, when I right click here, statistics, and we can choose mean. So we get our average meal price and our wait time. So we can quickly see that restaurants rated good. The average meal price was $19 and the wait time was 2.5 minutes. But in the restaurants rated excellent, the meal price on an average was $34, and then the wait time was 32 minutes as well. So this is a very quick pivot table that we can do in JMP. But we can do more than that. We can also start again using the binning of columns. Let's say we're interested in figuring out our meal time sliced by our meal prices, and instead of looking at just the discrete data, we'll create some bins, maybe of $10 each, and our quality rating. So then we select this, we go to our columns, look at column utilities, and we'll create binning columns where we wanted bins by $10, but we could have adjusted that. If we wanted $5 or $15, we can either type in here or we can adjust with these handles. But this looks good the way we want it. We click on Make Formula Column. And now we have a binning column for our prices. So I'm going to again go to Analyze and click on Tabulate. In this case, we will move our quality rating to our rows, but now we want to move our bin price to our columns. So now we get our numbers for each combination of quality rating and meal price. Now I'm going to drag my wait time and then put it in the data. And here again, it's sum. We don't want sum. We can kind of right click, and then statistics, we can look at mean. So now we get our average wait times. Again, we just chose mean, but again, you can see that there are a bunch of other statistics. We'll talk about what standard deviation, variance, etc. are later on. But here we are just getting a quick snapshot. We have kind of gotten a pivot table where we have our columns as the bins of meal prices, and then our rows are the quality rating. And we see that cheaper restaurants, which are rated as good, there's very little average wait time. But then in excellent restaurants, which are more expensive as well, there is a larger wait time, 32 minutes on an average. And of course, we have no restaurant which is rated good and which is that expensive. So again, tabulations or cross tabulations, because we are now tabulating data set which is mean of wait times by both the rows and the columns, which are average or price bins. It's called a cross tabulation. It's a very powerful technique, and in JMP we can do that fairly smoothly. Now, as our final illustration, we will look at bar charts. Again, this is data on cell phone usage by age of various consumers. And then we also have, so this is again a cross tabulation already, but we want to be able to draw bar charts. So we have to first again stack them, because these are really our percentage usages. Again, it's classified by age and smartphone usage. So I'm going to select these columns, go to my table, click on stack. We'll drag these three to our stacking column. We click OK. So now we have a data set which is nicely stacked, and we can start leveraging this tidy data format into various graphs. So we go to the graph builder, or we can start by age. So what I'll do is I'm going to classify with each age band what is the percentage of users having a smartphone, then other cell phone, or no cell phone. So we drag our age label to our x-axis. We drag our data to our y-axis. Now this kind of, and then let's make it into a bar chart. So this looks weird because everything is equally stacked, because when we combine the age group within each cell, the numbers will add up to 100. But we have our labels of smartphone, cell phone, or other phone, which, as we have seen before, are overlay. So I'm going to drag this to my overlay. And the moment we do that, we get these nice colors. We get no cell phone, smartphone, and other cell phone for each of these age categories. So this is what we call a side-by-side or clustered bar chart. But so again, this is a very quick way of looking at how our category, which is the type of cell phone, gets broken down with each age group. But if I click on stacked, we can see now that each of these stacks equals 100, as that what we had seen before. But now we see the various age distribution or cell phone distributions by age group. So we see that there is a large number of users in the senior age group category, 44%, who do not have a cell phone. And among young adults, we have only a small fraction which don't have a cell phone. And in fact, we have most of them with basic phone, but we have the highest group of smartphones in the 25 to 34 age group. So again, this is a quick way of looking at our data using the two different kind of bar charts, a clustered bar chart as well as a stacked bar chart, where the stacks then add up to 100% for each of these subcategories.